Hi everyone, welcome to another webinar held by the Methanol Institute. Today we're going to have a webinar based on or focused on methanol as a diesel substitute. Before we begin today's webinar, just a couple of items that the audience should keep in mind. Firstly, you're on mute, so don't worry about making any noises in the background, but because you're on mute, you won't be able to give or provide your questions verbally during the Q&A session. So what I would like to draw your attention to is the control panel on your screen. And there is a tab there. There are a number of tabs there. One of them says questions. If you click on it, it's a drop-down menu. And that's going to be where you can type in your questions and we'll receive them. The Q&A session will be at the end of after all the presentations. So we will be going through your questions when we are done with presentation. So do keep your questions coming in. The second thing I would like to point out would be below the questions tab would be this tab called handouts. If you click down on it, there is a drop-down menu. It'll allow you to download the PDF version of the webinar slides today. So those are the two things to remember. Remember to send in your questions and also download the handout before you log out of today's session. So without ado, without waiting, I'll go into a quick introduction of today's topic as well as the Methanol Institute. So MI was founded more than 30 years ago. I mean, it was in 1989. We were founded in Washington, D.C. Right now, we are in 5 offices around the world. From D.C., there's Brussels, Delhi, Singapore, and Beijing. So MI is the global trade association for the methanol industry. We represent anybody that is within the industry, from methanol producers, distributors, companies that are developing technologies that utilize or produce methanol. So these are some of the companies within our membership. To kickstart today's session, what I would like to do is play a short video just to give you a quick introduction to methanol as a product. So bear with me, I'm gonna start playing this.
In a fast-changing world, it is time to find innovative and efficient solutions to provide future-proof fuels. As the simplest alcohol, methanol comprises of hydrogen, oxygen, and a single carbon atom. It has the highest hydrogen to carbon ratio of any liquid fuel. These chemical properties contribute to methanol's sustainability as a petrochemical feedstock and fuel. Methanol is commonly produced from natural gas. Increasingly, methanol is produced from renewable feedstocks such as renewable energy and carbon capture, municipal waste, and agricultural waste. Methanol produced from such feedstocks creates circular economies, where what is normally deemed waste is used to produce methanol, which is a useful and higher value product. Such processes effectively promote sustainability by creating value from waste and diversifying how waste is managed. Methanol is used to produce a wide range of ubiquitous products, such as materials for constructing houses, paints, plastics, car parts, and medical equipment such as personal protective equipment. When produced from renewable feedstocks, renewable methanol becomes a sustainable, net carbon neutral fuel, compliant with climate goals. Upon combustion, methanol's chemical compound and physical properties result in significantly lower emissions. Specifically, the absence of carbon-to-carbon bonds in methanol molecules is key to the negligible emission of soot or particulate matter, and the oxygen atom contributes to a fuller and cleaner combustion, making methanol an environment-friendly fuel that contributes to better air quality. As one of the most widely traded commodities in the world, methanol is available at more than 100 ports around the world. This reduces infrastructure costs for the marine industry to transition to methanol. Conventional methanol reduces emission of sulfur oxides by 99%. nitrogen oxides by 60%, and particulate matter by 95%. Net carbon neutral renewable methanol will meet the International Maritime Organization's goal of reducing greenhouse gas emissions by 50% by 2050. Inland transport, methanol can be blended with gasoline or used as a standalone fuel in order to boost fuel quality and efficiency while lowering emissions. To improve air quality with a cost-efficient solution, China is fueling land transport vehicles with pure methanol. Iceland is fueling a fleet of cars with renewable methanol. Italy is blending A20, a blend of methanol, ethanol and gasoline. This blend is being demonstrated in a car-sharing fleet with plans for it to be made available to consumers. The United States uses methanol regularly in motorsports. Certain regions in China, India, Nigeria and Tanzania have adopted methanol as an alternative fuel for cook stoves. Methanol's clean burning properties improve indoor air quality, lowering the risk of respiratory diseases. Methanol is also being used in fuel cells to produce electricity in applications like range extenders in electric vehicles, propulsion for marine vessels, unmanned aerial vehicles, telecommunication towers, and military equipment. As a liquid at room temperature and pressure, methanol is a convenient hydrogen carrier for fuel cells. Increasingly, methanol is being used as a fuel in industrial boilers to produce heat or steam for the pharmaceutical and manufacturing industries. The methanol burner used in industrial boilers is also being used in other applications, such as producing heat for drying tea leaves or tobacco, ceramic sintering, and residential heating. As you can see, there are no shortages of available applications for methanol as a clean and net carbon-neutral fuel. Methanol is the key to a more energy-efficient and clean future.
Okay, so let's go back to the slideshow. Okay, so these are some of MI's members, as I mentioned before the video earlier. We have methanol producers up in the top tiers, and they trickle down to some of the smaller companies that develop technologies that go into methanol production and methanol utilization as an energy product. So these are our contact details. And as I mentioned earlier, we are in 5 offices around the world. If you have any queries or any interest in methanol as a product, the industry, or any kind of general questions that you'd like to have answered, do feel free to reach out to us. So to start off with today's session, I would like to introduce our first speaker today. Our first speaker is Gil Dankner. He is the president and chairman of Dor Motors. So I'm going to pass Gil's controls right now so he's able to move through the slide deck. Gil, please.
Well, good day, everyone. Thank you for the invitation, and I must tell you that it's an exciting era for anyone who's part of the revolution for finding a new energy source as a replacement to oil-based energy, whether it's diesel or gasoline, which have been the primary source of energy for the past 100 years. And indeed, it's exciting, and methanol can become a significant part of this revolution. I would like first to start with the market potential at which we are talking about. I have difficulty. Okay.
Bill, I'll help you control the slides.
Okay, yeah, thanks. So the diesel market is 1.3 billion tons per annum. 75% of it is for transportation. I mean, when we try and grasp this figure of 1.3 billion tons per annum, it means that we have an endless potential, whether it's methanol or any other alternative fuel. Within this market, I will introduce two applications. One is for transportation, for commercial vehicles, and the other one is for generators. So practically worldwide, there are 15 million trucks produced annually, out of which 12 million are light and medium-sized trucks. And as far as generators, it's an increasing market of roughly $20 billion per annum, all of which is, or primarily, is being used with diesel. Next slide. Okay. So, I mean, and still, as far as methanol, we do have to realize that there are some challenges to look into in order to be able and make methanol an acceptable fuel. One of which has to do with the machinery, with the engine, and the other aspect is the chemistry. We call it Dor mix. This is to say both the additives that we have to add to the methanol, as well as additives we have to add to the engine, like the special lubricants. And these I will now talk about. I just lost you. Okay, sorry. So let's start with the generators. As I mentioned, it's a $20 billion market, $20 billion market. And what we've done is we've been able to manufacture generators of both medium and small size, as well as large size generators that replace 100% diesel with 100% methanol. We first and foremost, the emissions are significantly been reduced. As we all know, methanol, when it is burned, and especially when it is burned at the right properties, there are no particles, and this is very significant, and a significant reduction in NOx, SOx, as well as CO2. So this is one application which is readily available using the Dor technology. The next application that I would like to share with you, this is a larger scale power plant, a 25 megawatt power plant based on a gas turbine, which again we replaced 100% diesel with 100% methanol. You can see here the reduction of emissions. What's very important to mention is that the total cost of kilowatt in both applications is reduced. Again, when we do the comparison, there are some markets where it will be much cheaper. There are markets where the kilowatt will be similar to when using diesel, but altogether, the beauty of methanol, not only it is a liquid fuel, which makes the material handling of it very easy, which means inexpensive, is that the total cost of kilowatt is similar to diesel, in some cases lower, and we received a significant decrease of emissions, and which means that we can get the necessary environmental demands without any extra cost. And this is the unique issue regarding using methanol, unlike other alternative fuels. So again, the methanol, being a liquid fuel, is easy to handle, easy to store, easy to transport, and the caloric cost of methanol as compared to diesel is similar or even lower. This application, what you see here, is a medium-sized truck, which we are replaced, and it is running on 100% methanol, along with our additives, the Dor mix. It is running smoothly. By the way, both the generators and the truck are also quite much, the noise aspect is lower than diesel, and also the maintenance is significantly lower than when using diesel, because of the fact that methanol is a pure molecule and it's burning very cleanly. And as you can see, this truck is running on 100% methanol. We don't need the SCR system in order to comply with the Euro 6. The SCR is what we normally use, the urea solution, which is added to the trucks in order to reduce emissions. When running on methanol, it is not necessary, and yet we comply with the Euro 6 emissions standard without the SCR, which is very costly, both when buying and when running. So it's really a significant improvement. By the way, I cannot overlook the fact that methanol does have some disadvantages, and we should put it on the table because these are some of the challenges we have to overcome. This is the fact that the caloric density is lower, as well as with the fact that methanol is a dry fuel and requires different material handling. Can you pass the next slide, please? Okay. So here we see the emission standard both in the US and in Europe for generators, and the important message I can convey to you is when running a genset with methanol, it's quite easy to comply with these regulations. And again, it makes the running cost easier and cheaper. Next one. So to sum up, these are the overall reduction in emissions for methanol as compared to diesel. When adding some of the additives, we can get even improved reductions of emissions. But again, the most significant point is that this is done at a relatively very low cost using existing infrastructure, whether it's internal combustion engine, a gas turbine, as well as the storage and distribution infrastructure. Next. So what are the challenges we are facing? We do need to do some modifications to the internal combustion engine. There is the issue of material compatibility throughout the chain. methanol does have its own properties, and we do need to understand the chemistry in order to overcome corrosion and wear. There are issues of health and safety. I mean, when methanol is burned, it burns almost in a way that you cannot see it. So there are precautions issues that we have to take care. And obviously, we have to provide the methanol chain supply and to make sure that it's there. Otherwise, no one will be interested in using it. Next. I would like to take just a few slides also in order to mention the work we've done with Fiat Chrysler as far as fuel blending, 15% methanol in gasoline, where actually here the major advantage was that there wasn't any significant change we had to make in the overall sedan in order to utilize M15. Next, please. And here you can see the emission difference, reduction of emission as compared to the raw 95 gasoline. And you can see a very significant reduction in emissions when blending 15% methanol into gasoline. And again, this at the end of the day, we achieve it with no additional cost to consumers. Next, please. These are the fuel M15 fuel standards which we have first started introducing in Israel, later on in Italy, and as well as India. And obviously, this is a fantastic achievement. Next. So what is our market potential? First of all, for generators, the electric vehicle revolution will require much more electricity, and we do get a lot of demand for gensets running on methanol in order to charge electric vehicles, especially buses in the cities. So this is a new application, and we are welcoming it. I would say that altogether, the main advantage for methanol will be in those markets where methanol is being produced. That's where the delta between marketing the methanol locally for energy is much more beneficial as compared to exporting it, as well as all those markets which practically in one way or another are placing duties or levies on the diesel, and this is something that makes the diesel more and more expensive, which implies that methanol will become much more competitive, whether it's methanol that is produced from natural gas or methanol that is and will be produced from alternative fuels and will become part of the overall idea and notion of recycling our energy and our resources. So I thank you very much for the opportunity, and I invite you to become part of this exciting revolution. Thank you.
Thank you, Gil. Thanks for that presentation. I think there will be many questions regarding what Dor Motors have done so far in Israel, but we'll keep them for the Q&A session at the end of this session. So I'll be moving on to our next speaker. Our next speaker is BJ Johnson from Clear Flame Engine Technologies. BJ, let me pass you controls and you can take it away. There you go.
Great. Good morning, everyone, or good afternoon, based on where you are. So my name is BJ Johnson. I'm co-founder and CEO at Clear Flame Engine Technologies. Looking forward to sharing with you our vision of how we can use methanol and other fuels to rapidly decarbonize heavy industry. And very happy to be going after Gil today, because a lot of what he explained about the benefits of methanol as a fuel to displace petroleum products certainly continue to expand into the technology that Clear Flame is going to be talking about. Great. So in terms of where Clear Flame is actually targeting to deploy our technology, we're big believers in electrification, and we think things like electric passenger cars can make a lot of sense in certain applications. That said, there are a huge range of markets out there, of which semi-trucks is one, but also things like agriculture and construction, where these markets are going to be reliant on liquid fuels for decades. And as Gil was saying, right now, if you're reliant on liquid fuels, that means you're reliant on gasoline or diesel. And so Clear Flame has a very similar vision of how we can target the 90% of the market that is going to remain liquid fueled, which means fossil fueled, for decades. So our solution is to deploy the diesel engine without the diesel fuel. So in contrast to some of what was just described, we are particularly targeting those applications that are reliant on the diesel cycle itself, its high torque and its high efficiency. The problem is not the diesel engine. It's actually one of the most efficient mobile conversion devices that we have. It's about as efficient as an automotive fuel cell. The problem is the fuel that we use in it. So what we have done at Clear Flame is effectively developed a parts kit. Think 80 to 90% of the parts of the engine remain unchanged. You integrate our solution into that engine design, and from there, we have a higher temperature combustion process that allows us to burn any decarbonized liquid fuel, such as methanol, in the diesel engine cycle. Now, the reason this matters is, as Gil was just saying, this is going to have very low carbon emissions. You will not need an SCR. You will not need a DPF. But for those that are reliant on diesel engines, the Clear Flame solution is not going to change performance at all for those users. It's not going to change the production and maintenance process for anyone who knows how to work on a diesel engine today. Yes, you need a methanol compliant fuel injector, but you're still installing that injector into an engine in the same way we are today. And I think most importantly, we can do this with just the regular methanol fuel that is already out there in the market today. We don't need a second fuel like diesel for ignition, and we don't need any sort of additives to be able to achieve our combustion process, which means that we can work in markets that might have access to methanol, but without the additives that could go with it. Sorry, there we go. So we have already demonstrated our solution on a 500 horsepower engine. That's about 373 kilowatts. The background of this photo is a Cummins X15. So this is the largest engine that Cummins sells into the US on-road market. We took that engine, we baselined it on diesel fuel, measured all of its operating points that a truck or a user would demand, integrated our technology, and ran it on an alcohol. We have run both ethanol and methanol in the past, by the way. We've been able to demonstrate that we can hit all of those operating points without the need for any diesel fuel and the stock methanol that is already out there and available, whether it's mixed with gasoline, mixed with water, or any other potential impurities. We've proven the technology on the Cummins engine platform, and we are putting it into trucks on the road in the fourth quarter of this year. So what this technology enables in terms of its value proposition pillars are really three core attributes that are critical for cost effectively mitigating emissions from the heavy duty sector. First and foremost, this has to be a low cost solution. Total cost of ownership has to pencil, which means you can't require a lot of upfront capital, either on the equipment or the infrastructure, and you can't increase operating costs with higher fuel costs. Similarly, we need solutions that are fast to implement. There's a lot of work being done on solutions that might be relevant in the 2040 to 2050 timeframe. But if we're serious about hitting our emissions goals, we need alternatives that are ready to go now. And to be clear, this can be competitive with any emissions reduction norm, as Gil was just mentioning, Euro 6 transitioning into Euro 7, what's happening here in the United States or in California at CARB, and at the international level in terms of carbon mitigation regulations. So this projection is just a corollary to that Bloomberg data that I showed, showing that there's going to be slow penetration of electric vehicles and fuel cells into heavy duty markets. The reality is, if you are stuck waiting on expansion of EV and hydrogen infrastructure, which we absolutely need to deploy resources to expand, you simply cannot outpace the carbon mitigation that you can achieve using fuels and infrastructure that are already scaled into markets, which means existing engine designs and existing decarbonized liquid fuels. And circling back to the economic case, again, while we are focused on emissions reduction and sustainability, solutions do not get adopted in these commercial sectors, the ones that are most reliant on diesel engines, unless they save operators money. Margins are very thin and people simply cannot pay extra to go green. And this is really one of ClearFlame's biggest advantages. By not adding any complexity to the truck itself, while also using low cost and readily available fuels, we can offer a lower total cost of ownership, meaning there is no longer a green premium to reduce the emissions of your operation. This, of course, is critical for accelerating adoption of drivetrains in cities that can improve air quality. So a lot of the focus in the world today and in the presentation so far has been on carbon, but knowing that we can improve soot, SOx, NOx, and all the other human health concerns associated with diesel is a major benefit that can't be overlooked. Now, I've talked about this technology mostly in the context of trucks, but I do want to indicate that this is capable of being used anywhere a diesel engine is used today, which includes not just trucks, but off-road equipment like construction and agriculture, and solutions like diesel generators. This, of course, is a massive market opportunity, both in terms of the commercial revenue that we can get from product sales, but also major new markets for fuels like methanol, as they all seek to displace diesel fuel in parallel. So, with the kind of concluding remarks today, I want to share a few thoughts of how I think ClearFlame has a chance to collaborate with the methanol ecosystem going forward. As I mentioned, we're going to be putting our first 2 trucks on the road in Q4 of this year, and we have partners lined up here in the United States to test those trucks, in this case using ethanol fuel, because in the United States, that's where we've lined up our fuel partners. We would love to be able to expand this into international opportunities or domestic opportunities where using methanol might be the preferred alternative to ethanol. These trucks are ready to go. We just need the fuel partner and the fleet that's ready to test them on another fuel besides just the ethanol alcohol. Also, we have a demonstration planned in 2022 in a microgrid. So one of the things that has been of great interest here in the United States of late is grid resiliency. What happens as we get lots of wind and lots of solar, and there becomes fluctuation in the electrical supply that's available on the grid? Well, historically, those demand fluctuations have been met by things like diesel generators or natural gas peaker plants. Using a technology like ClearFlame's, you can operate at very high efficiency and provide on-demand power, but without the emissions and cost challenges of diesel fuel by using that lower cost alcohol. Again, this is currently a US demonstration planned with ethanol, but we would love to get a parallel demonstration on methanol going as well. And finally, I should definitely point out here that this is not just about new engines and new pieces of equipment. There are millions and millions of diesel engines on the road and in fields that are going to persist there for decades. And a solution that is fundamentally retrofittable, like ClearFlame's, is also going to be very important to not make sure we're slowing the expansion and growth of diesel going forward, but that we're also doing something about those assets that are already in the field and are going to remain big polluters for a long time unless we find a retrofit alternative. Now, final point I have on the methanol infrastructure today is a little bit of messaging that I think can help here in the United States and in Europe as well, which is the potential for methanol to be a hydrogen carrier and expand energy access. So right now, we know that there is need for hydrogen infrastructure out there, but there's currently no demand for hydrogen fuel because we don't have fuel cell vehicles yet. We can build methanol stations today that are low cost using liquids, and those methanol stations are going to be viable because they can deploy fuel right away into technologies like Dor's and into ClearFlame's. But at the same time, that methanol, once it's already distributed, can be reformed to hydrogen, which means in the future, we can have dual fuel stations that provide both hydrogen and methanol to the market. This is not to say that hydrogen or methanol, one is better than the other, but I think the more that we can show that these solutions are working together and working together in a way that can start to have immediate impact, I think that's a great way to get the policy support we need to expand into the market. So wrapping up, at ClearFlame, our vision is to provide a easy to adopt, fast to market solution that can enable rapid carbon mitigation without sacrificing any heavy duty performance. And we can do that without a lot of infrastructure development, without decarbonization of our electrical grid, and perhaps most importantly, not requiring users to change the way they're getting their jobs done today. So thank you very much for your time. I look forward to taking any questions at the end of the presentation and exploring how ClearFlame can work with the methanol sector to prove there's a faster and more cost-effective way to decarbonize heavy-duty industry. Thank you.
Thank you, BJ. That was a really interesting presentation, and I think we will certainly have a lot to talk about after this webinar. But for now, let's go on to our next speaker. Our next speaker is Mikhail from Aalto University. Mikhail, I passed you controls already, so feel free to start when you're ready.
All right, well, thank you, Tim. Good afternoon, everyone. Thank you for this invitation. It's a pleasure to present our activities in the methanol-related research in our research group at Aalto University. And today I will focus on the end-use perspective, so mainly internal combustion engines, and also from the perspective of the shipping industry. Okay, so let's start. I think that should work. So I will focus on this end-use application, but also I will give you some highlights regarding our other activities related to the whole value chain considerations of the methanol. And my previous, the former speakers just introduced the methanol pretty well and also highlighted the benefits. So I think it's clear that methanol is a very promising option. But I would like to start with this figure where we have the pyramid and this kind of challenge of decarbonization of transport. And if we go to the bottom to this pyramid, so we see that readiness of electrification is pretty high, especially for the light-duty vehicles or rail. But if we go to the higher levels, so other sectors, so then we highly need liquid or liquefied fuels. And focusing on the marine sector, so at the moment there is a huge room for activities in decarbonization. At the moment we have only 0.1% of low carbon fuels. So that's a very big room for greening solutions. And we have, for the shipping, we have few options over there, like liquid biofuels, then electrofuels, then maybe some forms of hybridization. But from this perspective, we picked the methanol as one of the most promising options for the marine transport. Of course, methanol at the moment is can be fossil-based. At the moment, like almost all the production comes from natural gas or coal. But in the future, what we could expect, so the growing importance of biofuels and electrofuels. So in that way, we also can produce methanol. that's the huge merit of methanol. And here I just listed the most important advantages of the methanol. So of course the liquid state in ambient, so that's the storage perspective for the shipping is very important, and we have already partly ready infrastructure in big harbors. Apart from that, methanol is miscible with water and biodegradable, and far less toxic than heavy fuel oil, for instance. Of course, as with all new technologies, we have some challenges to be properly addressed. So one is related to the energy density of methanol, but it can be overcome. So here, for example, those bigger onboard tanks. Maybe some additional safety measures on board, and of course cost. So that's in the future, I think, it should be properly addressed. But now let me move to the core part of this presentation, so methanol combustion in compression ignition engines. So for the shipping purposes, due to very high efficiency of compression ignition engines, we can try to use methanol in two different concepts. So one is direct injection of methanol. So here we can have some ignition improvers blended with methanol, or direct injection of methanol and then pilot diesel injection. And the second concept, so the port fuel injection. So here we have the conventional pure fuel combustion or reactivity controlled compression ignition combustion. How those concepts are represented in the market? So there are already some commercially proven technologies. So in the marine sector, we could see, for example, the Varsila direct injection system in the 4-stroke medium-speed engine, successfully demonstrated. Then we have 2-stroke low-speed engines from MAN, and also direct injection. And also another concept, so this port fuel injection, we have the diesel direct injection, and we have also the port fuel injection of Metamode. Of course, so far there is a low market penetration, but we can observe those big environmental gains compared to marine diesel, for instance. And how we as a research institution can support these activities. So we are trying to also lead experiments and understand the physics inside the combustion chamber. And here is one example we tried with the direct injection. So this first concept I introduced, direct injection of methanol with non-premixed dual fuel combustion. And what's interesting over here, so in our group we designed our own cylinder head with two separate injectors, and it was a modified single-cylinder research engine we are using in our lab. And the key results from this experiment, so we reached 44% of thermal efficiency. And it turned out that methanol, as a main fuel at high loads, can lead to stable combustion and robust ignition characteristics, increased thermal efficiency, and lower local emissions like unburned hydrocarbons and carbon monoxide. Those results are already available, so we could check in the references. And currently, so we are those experiments are followed by simulations. So now we are trying to understand the physics inside the cylinder of this new concept, and the results we are obtaining will serve for further dual fuel and methanol simulations. Here are some insights on the modeling we did in our the modeling, the simulations we did with the methanol direct injection. And here, as you could see, that the simulation pretty nicely mimics the experimental results when it comes to the pressure, cylinder pressure, and heat release rate. Okay, and here I would like to show you the animation of direct injection of methanol. So here you see the temperature isosurfaces and particles diameters. So first we have the pilot injection of diesel, the ignition of diesel, and then injection of the methanol as a main fuel, and ignition of the whole mixture. Okay. So that was the previous slides were related to the direct injection. So now I will have a few words about methanol port fuel injection. And it's more conventional dual fuel concept, but we have done one innovation over here with negative valve overlap. So some portion of the exhaust gases are trapped inside the cylinder. And it functions as internal EGRs, or internal gas recirculations. And the results are not published yet, but are very promising. So we obtained pretty stable combustion with quite high thermal efficiency and pretty low emissions with very high methanol substitution. I mean substitution, so how much diesel is substituted by methanol. And here you can see more insights. Pilot ratio is 10%. Then you can see the engine load varying from 40 to 80%. And very high combustion efficiency, and also very high thermal efficiency, reaching in the highest point, like almost 56%. And at the same time, having lower local emissions. So now a few words about more fundamental studies. So as you might know, the spray is a very critical parameter for the compression emission engines, which affects the engine efficiency. And we were also studying 2 years ago how methanol spray behaves in the combustion chamber. And the conclusion out of this study was that we have relatively similar spray behavior, so in terms of spray penetration and opening angle when compared to light fuel oil. But methanol has had smaller droplets than light fuel oils. And those experimental studies were accompanied by simulations. In that respect, the large eddy simulations, just to understand the fuel spray mixing and evaporation. And those simulations were pretty in line with experiments, so there were no big differences between light fuel oil and methanol fuel. But of course, the lower temperature within the spray was caused by the higher heat of vaporization for methanol. Okay, so then at the end of my presentation, I would like to give you some highlights regarding the whole value chain assessment. So in our research group of energy conversion, headed by Professor Mark Tilarni, we covered the whole value chain related to energy carriers, so starting from the conversion, then energy, and use and recovery. And one important aspect when we speak about methanol as diesel substitution is where we will have our methanol, renewable methanol from. So here is an example of study of our group. So first, on the left-hand side, you could see the techno-economic assessment of industrial scale methanol plant. Then it is followed by numerical performance study of methanol synthesis reactor. And finally, we have construction of the lab scale, pilot scale reactor, which is just being commissioned. Then going to the end-use performance assessment, so we contributed to the Horizon project funded by EU Commission. You can find more information on the website. And the methanol was identified as one of the most promising transport fuel candidates. And in Advanced Fuel project, so we created a tool which can assess different fuel options from the end-use perspective, including methanol. And finally, as we have both production and end use, we also need legislation in place and also appropriate environment to support the market uptake of methanol. And in the Advanced Fuel project, we have also really good collaboration with other partners related to all value chains parts, where we identified the most significant policy gaps and what interventions are needed. And upcoming work will identify also the methanol as a key fuel for hard-to-abate sector, especially the maritime. Yeah, and at the end, I would like to acknowledge the support and contribution to this presentation from my colleagues, Professor Mark Tilari, Ossi Kadio, Zeshan Archman, and Levi Salomon, and a whole group of research group of energy conversion. As you could see from the list of publications, the methanol is currently a very hot topic, and just news from today, that our research group got funding from Jan Saben's donation. So we are now even more focusing on methanol. So with that, I would like to conclude and thank you for this opportunity.
Thank you, Mikhail. As mentioned earlier, I would like to remind the audience to send in your questions. We've been receiving them, but we'll be addressing them right after the last presentation for today. And for the last presentation today, we have Jan Bruger from Fuel Safe. Jan, when it's, let me see if I can pass controls to you. And you can start when you're ready.
Okay. Hi, hello everybody. My name is Jan from FuelSafe. I'm today replacing Mark, our COO. CEO, sorry, I'm the COO. And as we had very, very interesting scientific input before, thanks for the many details and very interesting aspects about the methanol itself. So I will keep concentrating on the aspects of our technology, what we are doing, what we are achieving in reality, and skip a little bit on the methanol benefits, because those have been clearly described before, even better than I could do. So FuelSafe is a German green technology startup, and we developed a hardware retrofit system to reduce emissions and operating costs on existing large engines. Because there's a gap between smaller engines like truck engines that can be more easy and be retrofitted to methanol. standard. It's way more complex due to the methanol energy content to do this on ships, for example, or on larger power plants. So we developed a hardware retrofit that is already being installed today, and let's say helping actively today to make fossil fuel diesel engines cleaner and more efficient. So I'm just checking. Where's the control, please? Where do I have to?
Just click on the slide. It should move.
It should move?
Yep. There you go.
Oh, perfect. Okay, so our mission is to help operators of combustion engines, and those can be, it's mainly in the maritime business, can be power plants, also in mining trains, everywhere where you have power supply, independent power supply that is fueled with diesel. So we see ourselves as a transitional element because we're helping existing fossil technology to become cleaner and better, because we are very sure and aware that fossil fuel, especially in shipping, will still be there in 2 or 3 decades until maybe alternative fuels are in the position and in the demand of the customers to replace current diesel fuel. So what we do, we use methanol not as a fuel replacement, we use methanol as an additive, meaning by numbers that we inject about 3 to 5% of the original fuel volume or fuel amount, 3 to 5% are injected as methanol into the air intake of the engine. We're injecting the methanol together with water and a separate hydrogen and oxygen gas mix. So this is our so-called synth gas. We inject those 4 additives into the intake of the engine, and by that we achieve several very positive aspects. Those have been already described technically by the presenters before. What we can influence with these mixtures is the flash point, the combustion temperature, ignition timing, reaction efficiency, also the premix phase, and other aspects. So in total, what we do, we inject the right amounts of additives at the right time according to the engine load into the air intake of the engine, but that we cool down the intake temperature of the engine and help the ignition process, especially in the combustion process, to become more comprehensive and efficient. So I will skip those technical installation details. What we achieve for our customer for the installations that we do, we had in first installations that we did with prototype installations on smaller engines, we had up to 25% of primary fuel reduction, meaning that 25% of the primary fuel, in this case it was diesel, had been cut due to our injections. We have tremendous maintenance and cost reduction coming from the reduced engine wear and tear. We clean even the engine from the inside. This happens due to the hydrogen, small steam explosions in the combustion process. We had clear loop oil prolongment in the use of the loop oil, and we can reduce carbon dioxide by up to 15%. That is due to the reduction of the primary fuel, up to 40% in particulate mass reduction. SOx reduction, of course, also related to the primary fuel reduction. We are very, very good at NOx reduction with the cooling effect and also the water that we utilize. We can achieve NOx reduction up to 80%. And resulting out of this particular mass reduction, we have up to 33% of black smoke, black carbon, or what you call smoke, usually reduction. So this is more or less the same numbers. So I will skip this for now, leaving you more time to ask questions. Our technology, we are still a startup, but our technology has been tested and field proven on an installation starting 2000. 15 for 2.5 years, meaning a real operated engine on board of a vessel, the MV Annette. It's one of the largest heavy lift crane ships in Europe. And there we achieved around 16% net OPEX savings, meaning that we reduce the primary fuel by a certain amount and are deducting all the operating material costs for electricity, for methanol, and even fresh water and compressed air. Meaning from the 25% gross savings we had on that auxiliary engine, we really had 16% in cost net savings, which is really a huge and great outcome for an additive setup. We also did, of course, some inspections. We wanted to assure and prove and demonstrate that the engine itself is not harmed by the acidification with methanol. So this has been approved by a renowned servicing company for this Volvo Penta engine, where we did the installation, and was also confirmed by the classification society that is approving this ship or the inspections, the DNV GL. So besides all the economic outcomes, it also has very positive outcomes on the engine behavior. We have a very good cleaning effect on the engine, meaning after some 100 hours of operation, the engine was even cleaner from the inside than it has been before, meaning we reduce deposits from the standard fossil fuel combustion, making the engine better and cleaner, and meaning more efficient. Our solution has also been lab proven by one of the leading labs in Europe, where also all the big engine manufacturers are testing their engines or certain hardware retrofits or new lube oils or additives to lube oils. There we also received the confirmation that this that our technology is not harming the engine in operation. In contrary, it's contributing to a longer engine lifetime and more harmonic operation. So this is a very technical chart. What you can see here, please question me anytime later on, is that we are harmonizing the engine operation, meaning the variation in each cylinder peak pressure is reduced. So this is a very technical term, but the peak pressure of each cylinder is a very good indication on how our engine is running and how efficient the engine is running. And this outcome, it has been demonstrated not by us, but by AVL, which is one of the largest engine builders actually and designers throughout the whole industry, at least in Europe. So they stated a better equal distribution of the fuel within the cylinders, a smoother engine run, and reduction of fuel consumption and mechanical stress. That is what methanol is able to really achieve within an engine. This is the same chart only for the peak pressure. We have slightly increased maximum cylinder pressures. That is what you can see on the right side. This is an indication for a higher efficiency of the combustion process. Now I want to talk shortly about what we are doing, because we are really doing current and actual installations of our technology. Our second project after the big pilot project in 2018 is we signed a contract with Van Oord. I think Van Oord, at least in maritime business, is very renowned. It's a specialized shipping company, and we are installing our technology currently on 4 engines with a total power of 16 megawatts. Also, it's quite a large engine installation, and there we include our own customized methanol storage tanks on board of that ship, because that is the typical issue that you have on ships. When you want to utilize methanol, you need storage for that, and we have solved that problem, and this will be the first installation of our customized design tanks on a Van Oord vessel. And just yesterday, we received the purchase order from Seadrill, which is for sure renowned drilling company, that installation will be even bigger. So we will install our technology on combined 48 megawatts of engine powers, meaning 6 engines with 1 methanol storage container. This will happen until beginning of next year. Yeah, so to wrap it up, FuelSafe and our technology is representing a sustainable clean fuel transition. So we see ourselves as element between today and the future of alternative fuels, and we decrease the cost for our customers, increase their green profile, and our solutions are paying off for themselves. Because if you want to achieve anything in any business, the customers don't really want to pay more for being green. That's the truth. So you need to offer solutions that are paying for themselves, so the customers are motivated and interested to invest into new technologies or alternative fuels or anything that is helping us. Thank you. I'm glad to answer any questions you might have.
Thank you, Jan. So now we'll move on to Q&A session. Let me just bring your questions up. We've been receiving your questions throughout the session, and let's try to go through some of them right now. Okay, so I would like to invite the speakers to come on back and turn on your webcam, as well as your mic when a question is directed at you. So I think we'll start with Gil first, because there were quite a number of questions here. So the first question, Gil, is are the genset and truck engines which operate on Dor mix running on compression ignition or spark ignition mode?
Yeah, they run on spark ignition.
Okay. And actually, I mean, well Gil, we're with you also. There is a question from one of the audience asking about some of the potential markets that you were talking about for Dor Motors, and he said that he realized that there were Japan and Taiwan were not highlighted. He would like to understand or perhaps hear your thoughts on what you think about those two markets, Japan and Taiwan.
Well, I don't know the details of the benchmark for methanol as compared to diesel in those specific markets, but in principle, methanol as a universal solution to diesel being competitive in price will probably be as competitive in Japan and Taiwan as in any other market.
Thanks, Gil. That's great. So next up, I think I want to open up this question to both Gil and BJ. And that is, how are regulations regarding methanol evolving? Can 100% methanol be fueled? I mean, can 100% methanol be used in trucks on, say, for example, German roads today? Well, the second question was maybe Iceland has approved this. Iceland does have a pilot project. But maybe I think what we want to know is your experience in your own markets and what the regulations are like that will support or maybe impede the development of the adoption of methanol as a fuel right now. So Gil or BJ, whoever wants to take it first.
Okay, we did have to introduce methanol and its differences to the different regulators in Israel, whether it's the Minister of Environment and Minister of Energy. There were some demands that we were asked to provide. However, once the regulator saw the advantage, and mainly from their point of view, the environmental advantage of methanol, they are very supportive, and therefore, for example, we were able to have the M15 fuel standard, which is quite unique for a small market like Israel to construct its own fuel standard. So altogether, we receive fantastic support from the regulators.
And I very much agree with that. Generally, there's an educational aspect that has to happen here. For example, in Europe, we hear a lot of concerns about tailpipe carbon regulation, which requires educating the policymakers on the realities of life cycle carbon accounting. That conversation goes well. Here in the United States, where ClearFlame is based, that is very much a central discussion point right now as we consider low carbon fuel standard type policies that incentivize fuels based on their carbon reduction potential. Those are the types of fuel agnostic policies that can treat ethanol equally with the other potential decarbonized liquid fuels out there. Although I think there's also still a very big educational push that's needed around the safety concerns of the fuel, which are certainly real, but also very much solvable with the right amount of public education. So there's work to be done, but the facts are generally favorable, and that's one that does well in the policy space.
Thanks, BJ. Thanks, Gil. So next question, BJ, we have two for you. I think I can combine them because it's really a comparison between methanol and ethanol in diesel cycle engines. One was a generic question like that, and the other one was on the level of soot that is produced when ethanol or methanol is used.
Yeah, so the ClearFlame technology, essentially by creating a high enough temperature environment, the difference between methanol and ethanol becomes negligible. You have to flow a higher flow rate of methanol than you do ethanol because it has a lower energy density. But if the energy flow rate is the same, all of the other combustion parameters are the same. So things like efficiency and torque are identical. Now to the second question, there are subtle differences in soot formation. For example, dating back to our time at Stanford, we know that ethanol and even methanol can form small amounts of soot in the plume. Ethanol certainly forms more because there's the carbon-carbon bond in it. But the realities of high temperature combustion ensure that whatever soot you do form, you essentially have completely oxidized it away and you have soot-free exhaust in the tailpipe for ethanol or methanol, although certainly it is easier to do for methanol because it doesn't have a carbon-carbon bond.
Thanks, BJ. I think we have one more question for you down here. Yeah, it was on the comparison between methanol and diesel and the energy efficiency that there's experienced in when the CI engine is run on methanol versus diesel. Do you guys have any thoughts on that?
Yes. So the key is if you keep it operating as a compression ignition engine, so a true diesel style engine, you can keep all of the thermal efficiency of the diesel cycle. So a diesel engine is in the high 40% efficiency. You can do that on diesel or on methanol. Now you do need 2.28 gallons of methanol to equal the energy content of a gallon of diesel. So to Gil's point, it has to be priced competitively based on its calorific value. But if you do that, then being able to operate at a diesel engine efficiency saves you the 10 to 15% efficiency, fuel economy, fuel cost penalty you would normally incur if you were to give up diesel engine efficiency.
Thank you, Vijay. So we have one question down here, but it seems like it's addressed to MI, which is probably, I think I'll take that question then. The question is, we have focused on transportation applications and uses, but how important, if at all, are chemical and other industrial uses of methanol? And can these be expanded as we transition to renewable methanol? So I think from an industry perspective, the petchem side of the business still remains a significant demand of methanol globally right now. So like it is definitely still important. It really is sort of the bedrock of the methanol industry, where methanol is used to produce derivative or downstream chemicals. As we expand into renewable methanol, so I think the difference here really is what is more urgent on the climate agenda. Are we talking about decarbonizing downstream chemicals at the moment, or are we talking about decarbonizing transport? And I would say that I think with these other chemical and other industrial applications that you are talking about, they are important, that's for sure, but it just seems that the need to discuss decarbonize transport is higher on the climate change agenda for now. But I believe we would be seeing those issues arise in the future when we talk about, for example, the issue of sustainable plastics, renewable plastics, for example. Those are some of the things that will be very, very much tied with the expansion of green or renewable methanol, where the feedstocks that are used are going to be more sustainably sourced. So that's probably the answer to your question. In essence, really, it's a question of which is higher on the agenda right now for climate change. So next up, let's see. I think we have a question for Jan down here. Wait, no, actually, no. I think we have one more question for BJ. Actually, let's give this to Gil then, because I want to hear his thoughts on the Israeli market. So, is methanol combustion here to stay, or will it face stiff competition once EV matures?
Well, as I mentioned, we do have more and more inquiries for methanol-based gensets, since the infrastructure for especially electric buses in the cities is not available. So they do need to charge those electric vehicles with methanol-based generators. However, and that's the main issue, in my presentation, I showed what is the diesel current market, and it's so huge that I don't see right now the issue of competition. I think that our challenge in market is to focus on how to introduce this technology and make it readily available.
Thanks, Gil. Yeah, I think so the reason why I gave that question to Gil on EVs was because he was talking about EV charging with the gensets that you guys have at Dor Motors. But I also want to reserve one question for you, BJ, before we go to our speakers who are talking about the marine sector. And there was an idea that you brought up just now about methanol and hydrogen being synergistic in some ways. And I think that's something that is very, very interesting that has probably, I mean, I think we should spend some time discussing about it, because there is a lot of attention on hydrogen right now, and everybody knows the challenges of bringing hydrogen to market. Definitely in the last session that we had, or the last webinar that we organized at MI, we did talk about methanol being that carrier of hydrogen, but you also took it one step further to talk about having the infrastructure to dispense methanol right now is going to support the adoption of hydrogen as an energy source in the future. So do you want to sort of flesh out that idea a little and maybe bring up your thoughts on that?
Yeah, happy to. And I think it builds nicely on what Gil just said in response to the EV versus methanol question. It's not EV or methanol, it's both. We're going to have both at the same time. I think it's the same story here with hydrogen and methanol. In fact, I think they're even more coupled together, because if we don't have good ways to make green hydrogen, it's hard to make green methanol. And so it very much just is part of the methanol as an energy carrier conversation. And I think when we are communicating methanol going out there today, an investment, a dollar that's invested in methanol infrastructure today does not mean a dollar that doesn't go to hydrogen infrastructure in the future. And because it is such a great hydrogen carrier, that if we just ship methanol around as a liquid fuel for the next, I don't know, decade, however long it takes for fuel cell vehicles to really kind of grow and expand, there will be use for that methanol fuel as a liquid at the gas stations to refuel combustion vehicles. As we get more fuel cell vehicles on the road, all you would have to do is take that same exact gas station, add a reformer to it, and then on site, you can turn that methanol back into hydrogen, leverage its hydrogen carrier benefits, and put it into a fuel cell vehicle. And the reason why I think this potential synergy is so important, and by the way, it's not an idea I can take credit for, but the reason why the synergy is important is if we let methanol get pitted as a competitor to hydrogen, there's a lot of headwinds that we run into. But by showing it can help enable hydrogen and just make it a market question of let's let the user decide whether they want to use methanol or hydrogen at the pump, that's, I think, going to be a really easy way to sell this type of technology to regulators and politicians, knowing that they're not placing a single bet on the future, but they're truly diversified. Does that make sense?
PJ. Yeah, no, I mean, completely. I think those are some of the issues that we are dealing with right now at MI with the Indian market. I mean, they just announced their interest in launching their national hydrogen mission. That's what they called it this year. It was announced by government, but I think that there were some people in the market that perceived that as a competition with methanol, because in 2016, the government announced their interest in launching a methanol economy in India. But what we're trying to show really is that there is no competition. And like you mentioned, every dollar spent on methanol infrastructure goes into building that future where hydrogen becomes a realistic, practical energy product. But first, we need somewhat of a step change process where, you know, we hit some of the targets that we can hit today, and that's what we can do with methanol, because even for methanol, the infrastructure is already available. It's a globally traded commodity. A lot of it can be leveraged for fuel applications. Thanks for your thoughts on that.
One other quick final thought, which is there's actually more hydrogen in a gallon of methanol than there is in a gallon of liquid hydrogen. And I don't mean that as a knock on hydrogen, just to say that methanol infrastructure is hydrogen infrastructure.
Thanks, Vijay. So next, I'd like to move on to Jan and Mikhail. We do have a question. I think I'll let both of you take it. And I think broadly it is, why does it seem that methanol is not gaining the traction that it's supposed to be getting in the marine sector when ammonia and hydrogen are heavily discussed? Jan, do you want to go first?
Yeah, if I may. What I would say, this is more marketing related, okay? Because methanol, I mean, methanol is not so much questions anymore. I mean, Wärtsilä, MAN, they are all presenting methanol engines. Yeah, I mean, there are a few at least pure methanol engines in the market. They have designed and are selling dual fuel or multi-fuel engines, which are foreseen also for methanol. So I would say methanol is already seen as a transitional element towards whatever alternative fuel future. So that's maybe why methanol is not so in the focus right now. It's more about ammonia and hydrogen, which from our perspective, yeah, are like elements that might become relevant in 10 to 30 years or whenever. I think that's the reason. It's because there's no technical reason for that, and no market reason. It's only about marketing and talking about the new stuff.
Thanks, Jan. Yeah, that's an interesting take. Mikhail, what do you think?
Totally agree that currently the hottest topic is hydrogen or ammonia. And I think this is caused by the fact that methanol is already proven engine concept, so it's already demonstrated in the market. Whereas ammonia and hydrogen, those are quite problematic chemical compounds, especially when it comes to the combustion concepts. And I think now the biggest problem is in the production capacities, especially for the renewable fuels. And as we have methanol, which is currently mostly from the fossil resources. So we are looking for different options. And of course, if I would decide at this moment, so I would definitely switch to methanol. But of course, the costs behind the methanol implementation in the shipping industry. And on the other hand, the lack of the production capacities of the renewable methanol, that might be the biggest problem at the moment. but it might change in the near future.
Thanks, Mikhail. Actually, we have one question for you, and I just saw it. I think it was something that you touched upon quite briefly. And the question is, how do you see the availability of CO2 as a raw material for methanol? And this is probably e-methanol production in the future. So would there be enough CO2 that we can locate for the production of e-methanol?
So of course we can argue that in the future, so then the CO2 streams will be more limited than they are right now. And of course when we switch to renewable sources, but still there are some industries like the cement industry or other industries which are dependent on the combustion of fuels. So then we should have some portion at least coming from kind of the waste streams of CO2. Of course, another concept is direct air capture, but here, of course, it's more problematic as the concentration of CO2 in the air is pretty low. So that's, I think, from the energy perspective, is problematic at this time.
So I'm gonna go to the next question, but I think this one will be for Mikhail, and then we'll go back to Jan again. So you were talking about these new cylinder heads that you're designing at Aalto University. Is this approach only for new built engines, or can it be also used to retrofit existing engines?
Yeah, so what we did in our lab, so basically with the commercial six-cylinder engine, converted into a single-cylinder research engine, and then the cylinder head was designed by ourselves and then installed on the engine. So it might be the option to retrofit the existing engines. So that's not only the solution for the new builds.
Thanks, Mikhail. Jan, we do have a question down here. I see that you've answered it on the questions tab, but I think this question is quite interesting, and some other people in the audience might want to know also. And that is, how much space does a fuel safe system require? Can it be installed on small vessels or trucks?
Yeah. So of course we are designing our technology to fit any possible application that can be possibly done. The question about sizing and space is not for trucks. For trucks, we have a very small, very condensed solution that can be installed relatively easy. But for larger engines, it's always the challenge to find the place to accommodate the methanol. Because as it is a low flash point fuel, you really have to engineer on a ship to find a location where you can put it. So that's why we designed our double-walled and containers and all the safety setup around it, which is quite complex but required by classification. So this is the challenge. If it's a smaller vessel or a larger vessel, we did, I would say, at least 300 case studies where we found a space for the methanol and also for our technology anytime. So it takes some time, it needs some engineering, but it's possible to be installed because it's modular. You can place one part maybe a few meters away. Some parts need to be in the engine room. The methanol storage normally needs to be somewhere on deck, and the rest is connected via pipings and cabling. So yes, it is possible to be installed on trucks also, and smaller vessels, and also normally on large vessels.
Thank you, Jan. So I think we're about time, but there are one or two more questions, and I think maybe I can take some of these because they pertain to methanol as a hydrogen carrier. Are there technologies, process engines developed where methanol can be used to generate hydrogen? Yes, there are methanol reformers that can be used. They range from small to larger sizes. They can be modular. They can be placed on vehicles, or they can be stationary installations where you can generate hydrogen on site. One more question, which is quite interesting, and I think I'm going to raise that, but I don't know if I really have an answer for that, because it's almost like the flip side of the previous question, which was about methanol as a hydrogen carrier. But this question is methanol a game changer in carbon dioxide storage technology? I think that's a really interesting question that we can think about. I have not really thought about it in that way, but what I have thought about is that producing methanol from sustainable feedstocks such as captured CO2, whether it is direct air capture, or you capture it off a flue stack, or you gasify waste or agricultural waste, you're actually recycling that CO2. So what happens is that instead of it being vented into the atmosphere at some point, you're creating this circular loop or a circular economy where that carbon atom can be recycled over different lifetimes in different products. So I think that's where we are looking at that's what we're focusing on when we talk about methanol in its relation to carbon dioxide. But in terms of storage, I think maybe you might be better off storing it in empty gas fuels or empty oil wells, unless you want to utilize that again. So I've not really thought about it. I think it's something to think about. So we are time today. I would really like to extend my sincere gratitude to all our speakers. Thank you for taking the time to share your knowledge and experience on the technologies that you guys have been working with. I would like to extend our sincere thanks to participants who have spent the last 1.5 hours with us also. We will be going through the questions that were conveyed. For some of those that we didn't have time to answer, we will see if our speakers can get to you after this session. So don't forget to download the handouts before you log out of this session. So don't forget to download those handouts. Otherwise, you won't be able to download them once you've logged out. So thank you once again, everybody, and have a great day ahead.
Thank you.
Thank you all.
Thank you all.